Hi class, this is Mr. Morris again, and today we're doing a set of notes on predicting products. Predicting products is really going to be building on some topics we've talked about before. You've learned how to write chemical equations, you've learned how to balance chemical equations, you've learned how to tell what type of reaction something is by looking at the chemical equation. But we're going to put that all together today, and we're going to look at some reactants and try to predict what that chemical reaction will produce. There's several different types of equations as we've learned, and based on the type of reactants we have, we're going to decide first what type of reaction is this, and then we'll predict what the products are going to be. To start with, we'll talk about synthesis reactions. We're going to also talk about decomposition, combustion, single replacement, and double replacement, all 5 types of reactions and some tricks on how to predict their products. Alright, let's start out kind of by recognizing them. So the first thing that I want you to notice with a synthesis reaction, it's always going to be 2 or more elements combining to form a compound. Alright, so if we give you a problem and you're supposed to predict the products, and it's a synthesis reaction, it will not have a compound involved. It's going to be just elements. Now it may be a diatomic element like O2 here, or it may be a monatomic element like aluminum. But we're always going to give you 2 or more elements combining together if it is a synthesis reaction. So that's how you recognize that it's synthesis. 2 or more elements, no compounds. So with this one, I see that it's aluminum and oxygen. So a couple things you need to do if we're going to write the formula for a compound. To get started, I want to make sure that I make the charges balance. So I'm going to write down some pre-work over here on the side. I've got aluminum and oxygen. Those are going to combine together. And I need to look at my periodic table in order to figure out what I'm going to do here. I've got a periodic table open right here. Now aluminum is over here. It's element number 13. And it's got a positive 3 charge. If you remember, silver is down here. Silver, zinc, aluminum. So positive 1 for silver, positive 2 for zinc, positive 3 for aluminum. So aluminum has a positive 3 charge. Okay, oxide is right here. And it's in group 6A or 16, which has a negative 2 charge. Alright, now I need to do my crisscross to make the charges balance. So the 2 is going to go on the aluminum, and the 3 is going to switch from aluminum to the oxygen. Al2O3 is the correct formula. Check to make sure that that can be reduced, and it can't. 2 to 3, a 2 to 3 ratio cannot be reduced. So we're going to write Al2O3. All that's left now is to balance it. We'll come back to that in a minute. Let's look at H2 and Br2. Alright, so they're diatomic, but it's still just an element reacting with another element, and all that 2 elements could do is combine. There's no compound for them to be switching places or anything. It's got to combine. So this is a synthesis reaction. I'm going to look at H and Br on the periodic table and find their charges. Remember, we always have to balance our charges when we're making a compound in this set of notes, with only a couple exceptions, and I'll talk about that in a minute. So H is in group 1, so that's positive 1. Br is in group 7A, which has a negative 1 charge, so positive 1, negative 1. You can see that those balance out. Those are neutral. So this is just HBr. Excuse my sloppy writing, HBr. Okay, and then we could balance these. Let's start with Al2O3, the synthesis of Al2O3. Well, I see that I've got 2 aluminums. I could start there, but let's check oxygen first. I've got 2 oxygen on the left. I've got 3 on the right. To reconcile that, I could put a 3 right here. That makes 6 oxygen. And I could put a 2 right here. That makes 6 oxygen. It also makes 2 times 2 gives us 4 aluminum, so I got to check the other side. I'm going to put a 4 right there. Now if you had started by balancing aluminum first, you would have put a 2, and you just need to erase that 2 and change it to 4. Just keep track of it as you change numbers. So our formula is, or our equation, our balanced equation is 4Al plus 3O2 yields 2Al2O3. There we go. All right, and looking at the next one, H2 and Br2 yields HBr. Well, I've got 2 hydrogen and 2 bromine on the left. I've got 1 of each on the right. Just multiply by 2 and we've got a balanced equation. If you'd like, you can put 1s in those lines, but we don't normally write 1s in a balanced equation, so that's up to you. Decomposition reactions. Okay, this one's different. I've got 1 reactant, and that 1 reactant is going to be a compound. If you only have 1 reactant, there's only one thing it can do. It can break up into more than 1. It could fall apart, break apart. And that's what decomposition is. It's breaking apart. So I have Cu and Br breaking apart. Now, what do we always have to do when we're checking elements? We've got to look at our periodic table again, but this time, if we're talking about just elements, we're only concerned about whether they're diatomic. Now, our diatomic elements are hydrogen, and then you go to 7 and make a 7. That's my favorite way of remembering it, is you find hydrogen and then go to 7 and make a 7. There's a total of 7 diatomic elements. So hydrogen, then go to element number 7, which is nitrogen over here in group 5A. Then from nitrogen, it goes over to oxygen, fluorine, chlorine, bromine, and iodine. You can see that it kind of makes a 7 shape there. And if we add those all up, there's 6 over here. And then there's 1 right there. So 7. Go to 7, make a 7. There's 7 diatomic elements. And those are going to have a subscript of 2 if they're alone as an element. So bromine is one of those. Copper is not. So I write copper. There's only 1 of those. There's a subscript of 1, which is understood. But bromine is a diatomic, so I have to write Br2. Now we want to balance it. But if you look at this, it happens to already be balanced. I have 1 copper over here on the left. I have 1 on the right. I have 2 bromine on the left. I have 2 bromine on the right. Not usually the case, but it is balanced this time. Okay, let's look at N2O3. All right, I've got nitrogen plus oxygen. Let's look at our periodic table again. Nitrogen is element number 7. Oxygen is right next to it. So they're both in the 7. Go to 7, make a 7. Nitrogen and oxygen are both diatomic elements. So I'm going to have to put a 2 for both of them. N2 and O2. All right, so now I just need to balance it. It looks like nitrogen is okay, but oxygen's not. I'm going to have to double oxygen here, put a 3 there to make it 6 on both sides. Now I've doubled the nitrogen, I've got to double it on the right side as well. So there's our balanced chemical equation for that. We got 3 more types of reactions, but I'm going to pause the video here. You may want to try a few examples from the practice if you want to give it a shot. Try it on your own.